Hello world, welcome to another video about a sorting algorithm. Today, we'll talk about counting sort. Unlike comparison-based sorting algorithms such as bubble, selection, and insertion that we've already seen, counting sort works by counting, obviously, instead of comparing the elements. Let's work through the algorithm with an example. We have a collection of colors to be sorted, and let's say the ordering of colors is as follows: green, yellow, orange, and red. So we're expecting the result to look like this. The first step is to build a frequency array where we count how many times each element has occurred. In this case, we record the number of times each color is seen in the input. Next, we convert this frequency array into a prefix sum. For every element starting from the second one, we add the current number to the previous one and store the result in the current cell. What do these numbers represent? The count corresponding to a color denotes the number of elements that appear before it. By looking at an element and its corresponding count in the prefix sum, we can determine at which position the element will be when the input is sorted. The next step is to go through the input in the reverse order. I'll tell you why that is in a bit. Look at its corresponding count and place it in the right position. So, starting at the end of the input, we have the green color. The corresponding number is 2, which means there are 2 colors that come before green, including the green we're currently looking at. So this will be at the second position in the output. After placing it there, we also need to update the prefix sum by decrementing the count, because there is one less number that will come before the current color. Next, we have the orange color with the count of 7. So we place it at the 7th position, which is index 6, as indices are 0 based, and decrement the count. We proceed in the same manner for the rest of the colors. Notice that the colors that are equal appear in the same relative order in the output as in the input. There are 3 elements with the color yellow. In the sorted version, the leftmost yellow in the input is still the leftmost yellow in the output. Counting sort is a stable sorting algorithm, an algorithm that preserves the ordering when elements are equal. By nature, a sorting algorithm groups elements that are equal, but a stable sorting algorithm additionally guarantees that in the group, the order is preserved, meaning the elements appear in the same order as they did in the input. The stability of counting sort variant we discussed comes from the fact that we traversed the input from the end. Let's take a look at what would happen if we had traversed from the beginning. We have 2 yellows. Let's mark them A and B for visual distinction. Looking at the count against yellow in our prefix sum, we see that this should go at position 5, that is index 4. And the next yellow in the input should go to index 3. As you can see, B came before A, unlike their order in the original array where A was before B. The relative ordering will be flipped if we traverse from the left. This is so because the counts indicate the number of elements that appear before the element. That is, the rightmost position the element can be placed at in the out. When we traverse from the end, we place that element in its rightmost position and decrement the count. Therefore, the upcoming elements that are equal to it will keep getting placed to the left, preserving the original order. And that's all for this one. Thanks for watching.